All right, now this is station 5. It's a mixed bag. So this is a mixture of all of the concepts that we've covered. The first one says points A, B, and C are collinear with point B between A and C. You should draw a picture of that. Point B is between A and C. The measure of AB is 4x minus 1. So this measure here is 4x minus 1. And BC is 2x plus 1. And the whole thing from A to C is 8x minus 4. We need to find the measures of AB, BC, and AC. But in order to do that, we need to solve for x. Now if you see here, this is parts of a segment. We're doing segment addition postulate. So I'm going to write part plus part equals whole. My first part is AB. Okay. My second part is BC. And my whole is AC. Now that matches up with my picture perfectly. That's the diagram. This is the equation. Now let's substitute in our values. AB is 4x minus 1. BC is 2x plus 1. And the whole thing, AC, is 8x minus 4. So now we have an equation that we can solve for x. Combine like terms, you get 6x, negative 1 plus 1 is nothing, 8x minus 4. Subtract 8x from each side, and I have negative 2x equals negative 4. So negative 2x equals negative 4. Divide both sides by negative 2. So now I know that my x is equal to 2. But it told us to find AB, BC, and AC. So we know that x is equal to 2. AB is 4x minus 1. So I have to substitute the 2 in for the x. 4 times 2 minus 1 is going to be the measure of AB. 4 times 2 is 8, minus 1 is 7. So AB is 7. BC is equal to 2x plus 1. So we're going to take 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. So BC has a measure of 5. And the last one, AC, is 8x minus 4. So 8 times 2 minus 4. 8 times 2 is 16, minus 4 is 12. So AC equals 12. So AC, BC, and AB. Those are the answers. Solve for each variable. I have some angle pair relationships I have to look at. Well, whenever I see two lines intersecting and creating what appears to be an X, I know that this angle and this angle are called vertical angles, and they're equal to each other. So I could write an equation, 3x plus 20 is equal to 5x minus 50. Okay? So let's solve for x first. Subtract 3x from each side. And I get, cancel, this is 20 equals 2x minus 50. Adding 50. And I get 70 equals 2x. This cancels. X equals 35. So we know now that x is equal to 35. So we got one variable. Well, there's nothing over here to compare with this y, but I do know that this angle here, this is awesome, because this is a straight line. So these two angles are a linear pair. That means they have to add to 180. So I know that, and I know that this x here is 35. So I'm going to substitute in 35 where I have the x. So 3 times 35 plus 20 plus y, they all have to add to 180. Three times 35, let's see, is 105, plus 20 plus y has to equal 180. That's 125 plus y equals 180. Subtracting. Y equals 55. Woo! Very good. Number 3. If the measure of LN is 32, so we know that this whole length of this segment is 32, what are the measures of LM and MN? This looks like a segment addition postulate. So I'm going to immediately write part plus part equals whole. My first part is LM from here to here. My second part is MN from here to here. And it equals the whole, which is LN. Now let's substitute in our values. LM is 3x plus 8 plus MN, which is 2x plus 4. It all equals the whole, and LN, which is 32. Now we have an equation. Solve for x. Combine like terms. That's 5x plus 12 equals 32. Minus 12 on each side. And I have 20. 5x equals 20. Divide by 5. So x is equal to 4. But it asks, what are the measures of LM and MN? So now I have to substitute the values. LM is 3x plus 8. So I'm going to substitute the value of 4 that I got where this x is. So 3 times 4 plus 8. 3 times 4 is 12 plus 8. So LM equals 20. Now let's find MN. MN is equal to 2x plus 4. Substitute in our value of x, which is 4. 2 times 4 plus 4. So MN is equal to 8 plus 4, which is 12. So now we've solved the whole problem. Very good. The next question says, what is the measure of an angle whose complement is 53? Well, we know that a complement has to add to 90 degrees. So x plus 53 has to equal 90, because complementary angles add to 90 degrees. So subtract 53 from each side, and we have x equals 37 degrees. Did we answer the question? What is the measure of the angle whose complement is 53? The measure of an angle whose complement is 53 is 37 degrees.